So hello, our team will be presenting the SQuAD dataset research paper, which just came 1 year before the attention is all you need paper published. So next. Yeah, the main task was of the dataset was to answer some queries or questions based on the comprehension or some context given in the document in the format of documents or paragraphs. And in this data set you had to find a particular phrase or smallest relevant information for that particular query or question. There were existing similar like data sets at that time like mctest, wikiqa and cbt, which we will discuss in deep in later slides. So next. Yeah, this is the photo from SQuAD 1.1 version, which we took from the website. And here, as you can see, the context or the paragraph is given, and based on that, there are some questions, and a model has to answer those questions in like fewest possible words or a phrase. And they also mark a few answers, which might be the possible answer for that. And based on that, they were evaluating the scores. So next. Yeah, the this was one of the existing similar data set at the time, which was like MC test, in which it was very similar to SQuAD data set, but in this they have provided MCQs with questions. So model has to answer from one of the like MCQs provided. So one of the options provided. Yeah, next. These were also like similar data set, but in this there were like word problems which model has to answer through equations and numeric values, and which was like simple than the reading comprehension task. Yeah, next. This is a wikiqa data set in which this dataset was like open domain, so in which they provided multiple documents, and from those documents, for a particular question the model had to select a particular sentence, so a whole sentence, and not a particular span. Okay, yeah, next. And this was the closed data set in which the model had to find the blank word or the next predict the next word based on the context or paragraph given. And here, as you can see, they have marked the priority of the word, or you can say attention of the word, which is required for answering the uh, query. Next. Yeah, so SQuAD satisfied SQuAD was very different from all this existing data set, because that didn't provide a list of answer of or choices like MC test. Then system must select the answer from all possible spans in the passage, and thus needing to cope with a fairly large number of candidates. So, and then there were uh, evaluation system also that SQuAD, in which SQuAD dataset uh, represented. So using dependencies trees and diversity and stratification, they like sorted it by difficulty, and they labeled the questions by their difficulty. And yeah, there were around one like question answer pairs on the data set, and there were total 536 articles, and which was like larger than MC test. And yeah, I'll like hand over to Bhavik.
Okay, so now we'll talk about the dataset collection. So one of the most crucial part in building the SQuAD dataset was the dataset collection process. They approached this thing in three stages. The first was curating passages, and then crowdsourcing the question answers, and then collecting additional answers to ensure that the model was robust. So for passage curation, they used Wikipedia's internal PageRank to retrieve the top 10,000 articles, and then randomly sampled 536 articles and extracted 23,000 paragraphs. Then these passage covered a diverse range of topics. After that, in this slide you can see on the right side, this was the interface that they used for crowdsourcing. In the starting, they gave some basic instructions on what the other person uh, wanted to do, and you can see that there is a small paragraph, and each and every person was required to make 4 to 5 questions per paragraph and select the shortest span which he considered uh, that as an answer for that particular question that he has created. Next slide. So they divided the data set the into three things. The first was the training set of 80%, and then development set for validation for 10%, and 10% for the test set. Next slide. So yeah, so to guide the crowdsourcing people, they also provided examples of good and bad questions and emphasizes the accuracy. They got a 97% HIT acceptance rate. Next slide. So yeah, so finally to strengthen the evaluation, they did this extra thing of collecting additional answers for each question, which ensured that there were at least three answers per questions, and uh, the workers were shown only the questions and paragraphs, and they were needed to select the shortest span and answer these questions. uh, about 2.6% of the questions were marked as unanswerable, and the rest contained at least three questions. Yeah, next.
Okay. So now I'll be moving on to data and analysis part. So since they have curated a data set of SQuAD here, so their task was to also give some statistics about this data set. So they did three sorts of statistics. They gave what sort of diversity is there in the answer types that the users are answering, and what is the difficulty of questions which the users have proposed. And they have tried to, they've tried to quantify these two terms using some existing this parsing trees and all. So this is a dependency tree. For each sentence, one can construct a dependency tree, and for that they use Stanford Core NLP library. Stanford, they themselves use this library. So they were constructing this dependency parse trees. Uh, and then the things which they were doing is so in order to know the diversity in answers, so what they did was they use this POS labeling, this POS labeling, like what is the part of the speech each word in this sentence is referring to. So they actually got to know that usually the answers are 32% of the times the answers are actually common noun phrases in the answers which users have given, and the rest 20% are made up of other phrases like adjective, verb phrases, and all. Uh, in order to answer how difficult the question answering was, they gave few parameters like lexical variation, syntactic variation, and all, and they manually labeled few of these question answers. 1 or 2 examples they manually labeled to know what sort of difficulty is there in answering those questions. So in order to quantify this, what they did was they given the question which the user has entered and the span which user has selected in the paragraph, they were constructing the dependency parse tree for the question and dependency parse tree for that answer, and they were answering what was the edit distance between these two trees. That is what they have mentioned as a syntactic divergence in that. And greater the syntactic divergence, they said the answer was more farther away from the actual question. So they proposed that this might pose a difficulty in answering those, and this is what they found. Very few answers had syntactic divergence of 8 or more. Usually they were only off by 2 or 3. And so now we'll be moving on to the methods which they have proposed.
So now moving on to the methods. Here we have considered, as you know, that if there are n number of words in a sentence, there will be LC2 possible spans. that we can consider. But instead of which is big O of L square, but instead of taking all of those as a possible answers, what they have done, they have used the consistency parse generator of the core NLP, and using that parse generator, they selected all of the constituents as the possible answers, uh, which will be verb phrase, noun phrase, etc. So to check the difficulty of the data set, they used four models. So first was the sliding window approach. That basically what they have done is that uh, considering previous key characters, we will giving the model that this would be the next particular character that should be predicted, next particular word that should have been predicted, and using this they have trained the model. And the second approach they have selected is the same sliding window but with distance-based extension. And uh, the one initially they used a random क्या कर रहे हो यार तुम लोग भाई एक सेकंड यार बीच में भावित आ जाता ये दोबारा बोलता हूँ
हाँ हाँ
so now we'll be seeing which particular models we used to check whether whether the data set is difficult enough for the other models to predict the answer. So the first of all, there was a random model that will be predicting all of the answers randomly. Then one is the sliding window approach. One model used sliding window approach in which the particular model is trained based on the inputs as the previous k words and the output as the next word. And same as the third model in which they just added the distance-based extension. And for the last fourth model, it was nothing but a logistic regression model. Next. So here you can see the basic example of a logistic regression model, where first of all we have, as we know that we have continuous features. So first of all, we discretize those continuous features in 10 equal size buckets, and there turns out to be 180 million features, in which most of the features are lexical features, and the model is mostly the output is mostly dependent on those lexical features. And if we remove those lexical features, the output will not be that correct. So these are the particular features that that they have used in logistic regression model. So some of the features include like the matching word frequency, uh, like matching bigram frequency, root match, the length of the word, span of the word frequency, and post tags that they have used, some lexical features, and the dependency tree path. So all these features are the most important features that the model is being trained on. Next. So if you see an example, let's say take a simple example where we have 6 weights. So these are the 6 weights, and this is a single bias. So, and these are those 6 variables in which we have used the count of positive lexicon, negative lexicon words, and these are the values. And these features we are using, and then we are calculating the probability of getting the sentiment as positive or a negative. So this is a simple logistic regression model. So here we have just a sigmoid function on the weight times the input x plus the bias. So on calculating, we can get the probability of getting the positive sentiment given those particular words as input is 0.7%, 0.7, which is 70%, and getting it as negative sentiment would be nothing but 30%.
So the ways in which they have actually evaluated how their logistic regression model is actually predicting the right answer is by using these two metrics, which is exact match. Let's suppose there is the model actually predicted a span which actually exists in the data set. So that would be exactly matching with that. Else, if there is not a perfect match, but some of the words in that span are matching with the model's prediction, then they're calculating the F1 score for that. And both these losses actually correspond to learning of that logistic regression model. So they actually found out that their model achieved a F1 score of 51%, whereas humans were still way better, like reaching 86% on the F1 score. And what they actually did was they did feature evaluations like the features which you saw before. They were very handcrafted features, like they were handcrafting these and they gave some criteria of how the value of these features would be. So what they did was they took out few features, and then on the remaining features they trained the model, and they actually found that if you were to remove lexical and dependency parse tree features, the F1 score gradually drastically drops to 30%. So which means that these two features are actually quite important. And for later features, removing them actually does not change the F1 score by much, so they could have dropped them initially itself. So the thing which they found was, although they were expecting that question answer which had high syntactic divergence, they would be difficult for the model, but they actually found that humans did not care about the syntactic divergence, and their performance was still very good. So they've left this as an open-ended question, like there was something missing, which obviously since they've handcrafted the features, so this was the thing which was missing. But later on we found in coming up papers in the next year, like people use attention and all to have good scores on these. So talking about the future aspects, only after a month after this paper was released, someone used an LSTM network, LSTM based model to do predictions on this SQuAD, and they got actually an F1 score of 77% on this. And actually in the coming years, like they also released SQuAD 2.0, and you can see that people have made better and better models using attention and all, and they have actually beaten human F1 score and achieved 93%. So so this was actually a great sort of a way to create a data set with the help of crowdsourcing and all. Else it would have been very hard to manually label the data. So they've taken some hard effort to do this crowdsourcing and manually labeling the data set, and people have been able to train language models for specific these tasks itself, this reading comprehension tasks using SQuAD dataset. So now that is it for this presentation. Thank you.